Alright, take 3. This hasn't been going very well. Alright, so begin talking about the pre-lab and the lab that we missed today. Sorry about that, by the way. First thing we need to think about is, what is work? Alright, I don't know if you've had it in class yet. Some of you have, some of you may not have. What you need to think about there is what it really is and how it works in the universe. You can't use the word in its own definition. But anyways, so we have work, right? So it's a concept in physics. And I'll let you think about it. Okay, yeah, so work is the change of potential energy on a system. So, for instance, when I take my juice cup here, my sippy cup, wow, I'm really not good at this. Alright, I have it on the desk. Then when I pick it up in the air, when I change its potential energy, right? So I've done work on that. There's been a net change in the potential energy of the system of the sippy cup. The same concept would go for, like, if you worked in a warehouse and if you picked up a pallet and you just moved it horizontally or across the floor from one position to another. If it's still at the same elevation, there's been no change in its potential energy. So there was no work done on that system. So in order for work to be done, it doesn't mean that you exert energy, because if I pick up a pallet and move it, I'm exerting energy. However, I have to leave potential energy in the system, or I have to remove it from it. Normally we think about putting it in, though. Just the convention we take. So, how does that apply to what this lab is about today? What we need to think about is that cart going up the track. It's going to do work, right? And so work is a state function. Do anybody know what a state function is? Waiting. Are you done yelling at your screen? Alright. So a state function is something that doesn't care about anything except for, a function that doesn't care about anything except for the beginning and the end. It doesn't matter what happens in between. So let's say, like we take that pallet in the warehouse again. If you take that pallet on a forklift and you pick it up and you put it on top of another pallet, and that's all you did, right next to where it was, you've done work on that. You moved it from a height A to a height B, and now it has more potential energy than it had before. Now if you take that same pallet and you pick it up and you drive around the warehouse with it and you go outside and do a wheelie and come back inside and put it right on that same pallet like you had before, you haven't done any more work to it, even though you did put a lot of energy into it. So in our systems, what we try to do is make sure that we minimize the energy that is wasted, like doing wheelies and cartwheels and cool stuff like that. So instead what we focus on is the fact that whatever happens in the beginning and whatever happens in the end is all that really matters. So for instance, on that ramp, I'm going to switch this around. Hopefully it still works. Alright. I've got a ramp, right? And the cart, that's a cart somehow in some weird dimension. Alright, it's going to go up the ramp, right? However, what's going on is there's energy being put into the cart, or being used up by the cart as it goes up the ramp. And it gets to a certain point and then it's got a higher potential energy than what it did before. So work has been done on the cart. That work has to be either equal to or less than the energy that's put into it. In most cases in our class, we're going to assume that they are equal to each other. We're not going to take into account friction or other things. We're going to take as being perfectly conserved. So that means then the energy we had to begin in that cart is 1/2 mv squared, right? And that's going to be equal to mgh. So 1/2 mass times volume squared equals mass times gravity times height. And this is the height, right? So I see immediately as I can cancel h, and I end up with, if I move it up here and solve for h equals v squared over 2g. Oh, that's a bad place to write it. H equals v squared over 2g. Still looks bad, but it's what it is, right? Alright, so this goes directly to that third question right there. Alright, is there anything about the angle? No. So the height, since it works as a state function, it doesn't care about what is going on with the angle. It doesn't care. I mean, if the ramp is, I'm going to draw 3 ramps really quick. Alright, if it's a really long one with a really small angle, or if it's a really steep one with a really big angle, it doesn't matter. As long as it's going the same distance up against gravity, that height, if that's the same, it's doing the same amount of work, no matter how long it takes it on the rampy part. So as long as that's clear, then this should be a simple task to do. So what we have to do, you're going to get a PDF file, and in it, what I'm going to be doing is describing a spring that has an energy in it. We'll call it KE. That's kinetic energy. Alright. You guys looked out, you didn't have to do this part. Alright. And then what we're going to do is we're going to use that KE to determine how far up a ramp. Actually, no, I want to go to the top of the ramp. So we're going to do like a meter long ramp. Alright, so you're going to figure that out. And I will have a sheet for you like I sent out last time. And this concludes the little movie. If you have any questions, email me. If I can write my email address out. I can't. franhw01@ipfw.edu, blah 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 blah. Alright. Yeah, and I'll be in my office for a lot of time tomorrow, so stop by and see me if you have any questions. I think I said it's due the last day. That's fine. If you don't get it done then, if you don't have it done then, bring it with you, and we can work on it in class after you take the post-test. I'm not trying to stress you guys out about this or anything like that, so if you don't have time, don't worry about it. We can work on it on that last lab day. Also, there'll be a, I'm posting right now a special credit, haha, a bonus, some work. It'll replace missing grades or your lowest grades. It won't hurt you though. I think I'm going to make it worth 15 points altogether, 5 for pre-labs, 10 for final tasks. So there's always that. Alright, that's it, and see you guys Wednesday.